going to be looking at volume of cylinders. And you can see right here, there is a formula specifically for volume of cylinders, although it does follow the same formula for all of our prisms that we had looked at before. Our volume before was area of the base times the height. And if you'll notice, obviously the cylinder has area in a circular fashion here. So formula for area of a circle, pi times radius squared, is our area of our base, and then we have times the height of the entire object. And we showed this before with rectangular prisms, but if you can find out how many cubes, because volume is always measured in cubes, how many cubes fit on that bottom layer, and then you decide, well, how many layers do you need to fill up the whole thing? So that's where the area of the base, that's the number of cubes that fit, times the height of the whole thing, will give you your volume. What's great is sometimes they tell you, on this one, they tell you 15 cubes will fit in the bottom. So if I had to find the area of this, it would be 15. That's how many cubes fit in the bottom, or the area of the base, times the height. And we see that over here as 10. And so we end up with 150 centimeters cubed, again, because we're writing down how many cubes we can fit inside that shape. We also have area of a cylinder. Now this one's kind of tricky. If you'll notice that if you take a cylinder, look, this lovely cylinder, and you have two circles on it, a circle on the top, circle on the bottom, and then this edge side here, if you cut it straight down the middle and unroll it, you end up with a rectangle. And hopefully you can see that the circumference, the distance around the top here, becomes how big or how long your rectangle is along the top. So what we're going to do with that is, if we unfold our cylinder, we get our rectangle and our circles. And if we want to find surface area, that means area of all the outside surfaces, we're going to take two circles. And so area of a circle is pi times radius squared, but we have two of them. So we'll find the area of a circle and multiply by 2. And then when we go to find the area of this piece here, remember the area of a rectangle is base times height, or in this case, it's going to be height of the shape times the circumference, that circular piece. And circumference of a circle is pi times diameter. So we end up with this height of the whole thing times pi times diameter. Big old formula there, but that's the one we use when we want to find the area of all the surfaces, surface area of a cylinder. So we're going to try that out here. And to start with, we have find the volume and surface area. Find the volume and surface area of the given cylinder. And so I'm going to start with volume. I'm going to write down, of course, my radius and my diameter. If we can get those out of the way, then it helps a lot when we use things in formulas. So here, my radius, that's the 3.5. which means my diameter is twice that, or 7. And then I'm even going to write that the height is 10 on this one. That way I just have all my numbers ready to go. So my volume is area of the base times height, but the base is a circle. So that's going to be pi times radius squared for my base times the height. Then I substitute all the numbers in that I know. 3.14 is my pi. My radius in this case is 3.5. And I'll have to square that. And my height here is 10. So always do exponents before you multiply for order of operations. And so I'm going to do 3.5 times 3.5. That's going to give me 3.14 times 12.25 times 10. And then multiply all that out. You'll end up with 384.64 centimeters cubed. So that is our volume, how much soup can fit inside this can. If we want to find surface area, I'm going to do this over here. It's going to be a little cramped, but I do want to show you one more thing on this side. So for surface area, our formula is pi times radius squared times 2. Ooh, I forgot the 2 there. Plus height times pi times diameter. So let's see if we can fit that in there. Let's see. So 2 times 3.14 times my radius again is 3.5, and I'm going to square it, plus my height, that's 10, times pi, 3.14, times diameter, in this case is 7. And notice that I don't have to do too much thinking. If I have the formula written and I have what each one equals, when I get to a letter, I just look up and say, oh, R is 3.5. The diameter is 7. Oh, I need a height. That's 10. So it's really easy to plug the numbers in without making too many mistakes. Again, I'm going to square this 3.5 first because that's what we need to do. Always do exponents before you multiply, and we're always going to multiply before we add. So in this case, we will end up with 2 times 3.14 times 12.25 plus the 10 times 3.14 times 7. And when we multiply all this out, we end up with 76.93 plus 219.8. And then our last step, we're adding those up. We get 296.73, and it's area, so we're doing squared. Area is always how many, wow, really moving this paper around today, how many squares fit within something. So there we are, our surface area, our volume. I'll even put surface area over here. Okay. So the last thing I kind of added in at the last minute is something that's also really important. Sometimes they give you the answer to the volume and want you to work backwards toward the either radius or the height or even the diameter or the circumference. So in this case, I'm going to use my formula, which is pi times radius squared times height as the volume equals the volume. And once I do that, I'm going to substitute in the things I know. I do know 3.14 is pi. I don't know the radius in this case, so I'm going to write radius squared. The height here is 5, according to this information right here. And then the volume is 1,570. So again, going through, I'm going to multiply these ones out together first. 5 times 3.14 is going to give us 15.7 times the radius squared equals 1,570. In solving my equation, I'm going to divide both sides by 15.7, and I get radius squared is approximately, I guess we need our approximately sign, 100. Now we haven't gotten to this part yet. We've skipped around, so here's a part you have not seen before. But we've talked a little bit that adding is the opposite of subtracting and multiplying is the opposite of dividing. We talked about using an exponent is the opposite of taking its root. And so if I want to undo the squared, I'm going to use its opposite. I'm going to take the square root. So in this case, the radius is going to be, I guess we'll say approximately again, and then we want to find out what number here times itself gives us 100, and that is 10. And we were looking for units, that was the inches. And so on this one, we get radius is 10 inches. So sometimes they'll give you the volume and you have to work backwards to find a missing number. So that is all area, surface area of a cylinder and volume of a cylinder. Goodbye.